In this recording, we'll do a brief review of the topics in Green Book Assignment Number 1, Functions, Equations, and Inequalities. First question involves completing the square. So this is a good completing the square question because it has an a value that is not 1. In other words, the number in front of x squared is a 2. So the first thing we're going to do is divide through everything by 2. Okay, that gets the a value to be 1. Alright, so I've got x squared minus 6x plus 2 equals 0. Now this is not a perfect squared trinomial. I want this number right here to be half of the b value squared. So I think about, okay, I'm going to take negative 6, divide it into 2, so that's negative 3, square it, and that's 9. That's the number I want in this place, but of course it's not. So the first thing I'm going to do is get that 2 over to the other side by subtracting 2 from both sides, and then I'm going to add in a 9 to both sides here. Therefore I've completed the square. Now you should be able to factor this perfect squared trinomial. X minus 3, which I therefore could write as x minus 3 squared. Great. Now we're 2 steps away from getting the x by itself. If you remember, we did this in class. You square root both sides, get rid of the square, gives you the square root of 7. Of course, when we square root a square, we don't just get x minus 3, we get the absolute value of x minus 3. That leads to x minus 3 equals plus or minus square root of 7. And then it's easy to get the x by itself by just adding 3 to both sides. Of course, that number can be stored as a decimal and checked with your calculator. Next question involves factoring by grouping. Okay, so if you're faced with an equation like this that has a cube in it and 4 terms, and they don't share a common factor, we're kind of stuck with our other factoring methods. So the way we introduced it this year is we said, okay, you're going to look at the first 2 terms and find their GCF. So that would be x squared, right? You're going to pull out an x squared from those, and you'd get x minus 2 in parentheses. Now it should be the same over here. If I took out the GCF for the last 2 terms, it should be 9, I would still get an x minus 2 in the parentheses if I made it the right kind of 9. We'll talk about that in a second. Okay? So I took out the x squared, I get x minus 2. Now we said that 9 was the GCF for both the last 2 terms, but we don't know if it should be a plus or a minus 9. It's not obvious. But what I do know is I need what's in parentheses to be the same for both set of factorizations. So I'm going to make it an x minus 2 over here to match this one in red. And the only way to make it work is to have a negative 9 here. We have to distribute a negative 9 to the x minus 2 to get negative 9x plus 18. From there, we group together what's in parentheses here, what's in parentheses here as a single factor. We group together the coefficients, the x squared minus 9, as a single factor. Okay, and if you distributed this out, you would see that it does in fact produce these 4 terms. Now our work isn't finished. We still need to factor this a little further. This is a greatest common factor. Excuse me, it's a difference of 2 squares. So you're going to factor that as x minus 3x plus 3. And then because each one of these factors can be set equal to 0, you're going to get the solutions 3, negative 3, and negative 2. Our next question involves an absolute value equation. Okay, if you've got an absolute value equation that's got extra terms that aren't part of the absolute value, or an extra factor or something, you want to first isolate that absolute value by getting rid of the minus 4. Next, we're going to split it up into 2 equations. So we're going to split it up into what it was exactly as it is, and then we're going to think about, well, what would be its opposite? Because what's in here could have been a positive or a negative, according to the concept of absolute value. So we're going to split it up into 2x plus 5 equals 7, and then what's in the parentheses, I'm going to make it opposite. Negative 2x minus 5 equals 7. Make sure you negate that 5. That's a common mistake. Both of those are easy for you to solve, I'm sure. You're going to get the answers 1 and negative 6. You should always check the solutions to absolute value equations, because sometimes there are extraneous roots. In this case, they both check. Let's extend that and look at an absolute value inequality. So oftentimes you'll get an absolute value inequality that says solve and graph. This one actually gives you the graph, and we've got 4 choices we have to choose from to determine which one matches. I don't know a great way to go about this question except to start working through the choices. So these are our four choices. The first one I'm going to eliminate because it's a greater than, and of course that would lead to open circles. So that one can't be. Choice 2. Well, again, to work out choice 2, we're going to solve this absolute value inequality as if it were an equation. So we're going to first turn the greater than or equal into an equals, and then just like we did in the previous question, we're going to split it up into two equations. One is the same as it was with the absolute values removed, just as if it's the positive of this. The other is its opposite, negative x minus 3. Each of those are easy to solve. So we come up with negative 1, negative 5. Those happen to be the endpoints. And then all I need to do is determine if it's shaded correctly. So I'll try a test point like 0. If 0 works in here, then it is the right type of shading because the graph shades towards 0. It includes 0 in the solution set. So I'll sub in a 0 for x, and I get 3. I take the absolute value of 3, and I still get 3. And 3 is greater than or equal to 2. So I circle 2. 2 is the correct choice. Question number 5 involves parabolas, applications. We have an object going up in the air. This is a very common question we looked at often. Projectile motion type question, and it's modeled by this function. So the first thing you'd want to do if you had this question is underline the key information. And this question actually has 3 parts embedded into it. So that's our key function right here. The first question, which I labeled 1, is a at what time question at the maximum height. So again, we're always asking about heights or times in these types of questions. This one, at the maximum height, key word there is at the axis of symmetry. Okay? So you've got your axis of symmetry formula, negative b over 2a. Sub in the 45 and the negative 16. Work that out. Round correctly. 1.4 seconds. Second question is easier. It just asks you to find the maximum height at that particular time that we just found, 1.4 seconds. So that's just a substitution question. Sub in that 1.4, let your calculator do the work, and you're going to end up with 38.6 feet. You should always use your intuition on these types of questions and ask yourself, does that even make any sense? And I think that's a reasonable height for the ball to have gone. Lastly, probably the most challenging question. It asks us to find the time when the ball hits the ground. And of course that's the type of question where h equals 0. That's what you need to infer there. When the ball hits the ground, its height is 0. So we're going to sub in a 0 for for h of t here, and then we're going to use the quadratic formula to solve for t. So I'm going to sub into the quadratic formula, sing your quadratic formula song, sub in that information, the a, b, and c values, let your calculator determine the times to the nearest tenth. Those times are negative 0.1 and 3.0 seconds. Of course, we can't have a negative time. It doesn't make sense in this context. Just 3.0 seconds. Now you should ask yourself, does that make sense? And of course, it's approximately double what it took to get to the maximum height. So that's reasonable. Next question involves inverse of a function. Okay. So inverse of function, we always said switch x and y, right? So I will do that first. I will switch the x and y. All right. Take this right here, switch its x and y, and I've got this. Now I need to solve for y. Notice all my choices are solved for y. So I multiply through by 2 to clear the fraction. And the last thing we do is just get the y by itself by adding 3. And that looks a lot like choice number 1. Last question. This is a composition of functions question. Okay? It's a g of f of x. So what we're going to first do is start with the f function. Well, the f function says it's just 2 over x plus 3. I'm going to sub that in to the g function, working from right to left as the arrow indicates. The g function says put 1 over whatever you're giving me. So I'm going to put 1 over that function, and then I just need to simplify this by simplifying the complex fraction. Multiply both top and bottom by x plus 3, and then we end up with x plus 3 over 2. So the answer is choice 3. Thanks for watching.